Hey guys, so I'm just doing a quick teardown video on this Itechworld 200 amp hour lithium phosphate battery. I've got two of these and you can see this one's I've already opened. So this is my other one. You can see it's fully intact. I've been using these for I've had them for about a year and a half. I haven't used them a huge amount. So I was using for camping and stuff in my 24 volt system I set up. I can put a link to that in the description. But basically I wanted to tear it open and see what was inside it. So I pulled this one open and I wondered why they were quite big for the size, because 200 amp hour other batteries are generally smaller, and now I know why. It's because they're using cylindrical cells. So as you can see, it's got lots of cylindrical cells in parallel, and there's 4 banks of them to make up the 12 volt battery. So I think the reason they've used these cylindrical cells is maybe because they wanted to have a higher discharge capacity. So I'm pretty sure cylindrical cells have a higher C rating, so they can discharge more current for their capacity. But the disadvantage is they do take up more space, so you have quite a bigger battery. So to get this open, I just got a screwdriver and basically stuck it on the edge of the lid here and just pried it away around, and it popped the glue. So I'll show you up under here. So this is a BMS. Seems to be pretty beefy BMS. Looks like a pretty decent size one. It's got, so basically what this is, so it comes off the negative terminal on the battery, goes through the BMS, and up to here. So this basically controls any current going in and out and protects the battery and the cells. So we've got 4 8-gauge cables on the negative and also 4 8-gauge cables on the positive. You can see there's 4 here. And basically they've run it so you'll have a negative 2 cables to here, 2 cables to here, and 2 positive cables here and 2 positive cables here. So they've got little copper bus bar on each side. And the reason they take it on both ends is to better balance the cells. So the current, because if you pull it only from one end, it's going to pull more current from the cells on this end, and you end up with an imbalance over the whole length. That's why they've done that, so that's a good idea. It's got these, just like this foam on the sides to protect the sides, and also had foam squash in here which I've pulled out. So to open this, I had to actually use a reciprocating saw and cut through the plastic because they've glued the cells onto the bottom down here, so I couldn't pull them out. So down the side here you can see this cable. This is basically the balance cables. So you'll see one of these for each bank of parallel cells. And that'll go to the BMS, and the BMS can monitor each bank. One disadvantage of having so many of these cells in parallel is the BMS can't actually monitor every single individual cell. So if you have one of these little cells that fails, the BMS won't really know. And that could create an issue because that could have a lot more heat generating through that one cell. So I do think prismatic batteries are better, because that way you can have every single cell is actually monitored, because they're not heaps of individual cells. They're usually like about 4 cells. So it'd be 4 200 amp hour cells. So basically you just have 4 of these instead. So this is actually a 16 cell configuration, so it's a 48 volt battery, but it's basically just be 4 of these instead of 16. So now that I've been using it for a year and a half, and I've taken it on a few camping trips and stuff, and I've run it up and down. It's probably done maybe 20, 30 cycles. I'm not 100% sure, but not a huge amount of work on it, considering they're supposed to last about 2,000 cycles at least and still have a capacity left. You just lose a fair bit of the capacity after about 2,000 cycles. So I'm going to do a full test and see how much actually is holding now. So I'll fully charge it up, and then I'll run my capacity tester and let it run for 20 hours and see how much it actually holds. Okay, so now I've got the battery fully charged up using a Vitron card controller. Now we're sitting at 14.2 volts. So what I'm going to do is plug it into this capacity tester. I'm changing it to 11 amps. So I'll do 11 amp pull and we'll start now. Okay, so pulling 150 watts. And I've got it set for 21 hours, so I'll come back tomorrow and see where we're sitting at. Alright, so it's 7:30 in the morning. Come back out here now and it's completed. So it cut off. So as you can see there, we've ended up with 188 amp hours. So it's a bit less than the rate of 200, but I guess it has been a year and a half. Well, I haven't tested it when it was brand new, so I'm not really sure, but we can see after about a year and a half, it's lost about, actually, not 12%, about 6% of the capacity. So I'm pretty sure for the new 240X Pro Itechworld batteries, they're using the prismatic cells, similar to these ones. Obviously the advantage is that they're more compact for the amount of size. Like, you know, this is 300 amp hours, so this is 4 of these makes a 300 amp hour battery, 12 volt, and you can see like it's size comparison. So I'll put my hand there, we'll come over here to this one, and you can see like how much more compact it is for the capacity. So basically they've just got like this big thick sheet of some sort of like perspex or something on top of it, and that was glued all the way around the outside with some silicone held in place. And then as you can see, we got the 4 positive cables going to each end of the bus bar there and to the positive terminal, and the same on the other side. You can see you got those 2 negative cables on one side and 2 going to the other side there, and then the balance cables and come through here, through that hole there, plug into the BMS. Yeah, so the cable we're using is this 8 AWG 200 degrees Celsius. So 200 degrees Celsius, basically like the silicon around it can handle high temperatures up to 200 degrees. So this just means that they can handle quite a bit of current for the size. So you can have about 100 amps running through one of these cables. The only problem is it will get very hot, which is not ideal. So 4 of these together can probably pull like 400 amps, but it'll get up to like 200 degrees. I think at like 80 degrees Celsius, these can handle 65 amps or something. So what's that, like 250 amps? And you'll be still getting pretty hot, the cables. So ideally, like, it'd be nicer to have some thicker ones, but these will do the job. So as I mentioned, I've had these for like a year and a half. I built them in a big 24 volt system I was using. So I was using these in series, running a 3000 watt inverter. And I was running like induction cooker, air fryer at the same time. Had no issues with it. Had no problems at all. Ran perfectly fine. So thanks for watching. Hope that information was useful to someone. Just thought I may as well throw it out there. If you got any questions, feel free to write below. Thanks, guys.